We need the first 15 perfect squares. Perfect square numbers are found by taking a number and multiplying it by itself. So 1 squared is 1 times 1, which equals 1. Who can raise their hand and tell me what 2 squared equals? Connor. 2 squared is 4. 3 squared, honesty, is 9. 4 squared, Cade, is 16. 5 squared, Angel, is 25. 6 squared, Julian, 36. 7 squared, I'm looking for somebody new to raise their hand. Anaya is 49. 8 squared, Jaden, 64. 9 squared, Shelby, 81. 10 squared, Jordan, 100. 11 squared, Martez, you want to raise your hand? Martez, 121. 12 squared, Mariah, are you raising your hand?
Nope.
Kiatha, 144. 13 squared, is 169. 14 squared, is 196. Our last one is 15 squared. 15 squared is 225. Today we've got supplement lesson number 1, simplifying square roots. We are going to be simplifying radicals using a factor tree. Again, this is a review from Algebra 1. This is not something new. Our rule, going back, our rule for square roots is that if x squared equals y, then x is the square root of y. It is shown with an example at the bottom. If 3 squared equals 9, then the square root of 9 is 3. Square roots usually have positive and negative answers. We will usually use the positive answer only. The only case when we are going to use the negative answer on these is if the problem tells us to, like on number 3. There is a negative sign out in front of it. Otherwise, we're just going to focus on the positive answers. All right, the examples on this particular slide should be quick and easy examples to complete, because these numbers are all perfect squares. If they are perfect squares, you do not have to show a factor tree like we will on other numbers. We can go straight to the answer. Who can raise their hand and tell me what the square root of 64 is? Cade. 8. The square root of 64 is 8. Again, we are just focusing on the positive answer unless they tell us otherwise. Number 2, who can raise their hand and tell me the square root of 81? Honesty. 9. Okay, and we are getting these because 64 is equal to 8 times 8. 81 is equal to 9 times 9. We are looking for the number that when multiplied by itself equals that number under the radical. On the last one, we want the negative square root of 141. Angel. Negative 12. We use the negative one on this one because of the negative sign out in front of the radical. The area of a square is given by the formula s squared, or a side squared. If the area of a square is 169 inches squared, what's each side? Or what is the length of each side? If it helps you to visualize this with a diagram, you can draw one. Okay, for the area of a square, we take the side length squared. So a side is just one of the sides. They should all 4 be the same. So side squared is equal to 169. In order to solve this, we have to square root both sides. That would get s by itself. Connor, what do we get as our answer? 13. What are our units? Inches. The product property of square roots. The square root of a times the square root of b is equal to the square root of a times b. To simplify a square root, you break it down into its prime factors. You then pair up factors to break out of radical jail. When they break out, they are stuck together forever and become one number. What you really need to have in this slide would be the title of it. For all of these examples, our directions are going to just be to simplify it if possible. So the slide before said that we are going to break down numbers into their prime factors. We do that by making what we call a factor tree. So we split this number into 2 numbers that divide into it. You cannot use the number 1 when you do this. So we cannot use 1 times 15. If 1 and another number are your only options, then the radical definitely cannot be simplified. You would just leave it alone. Here, do we have another option? Cade. 3 times 5. So 15 can be broken down into 3 times 5. Can either of those numbers be broken down further? No. Okay, if we can't use 1, those 2 numbers cannot be broken down any further. Do we have any pairs listed here once we break it down? No. So is this radical going to simplify? No. So we would rewrite our answer as just the same as the original problem. But we showed that we looked for an answer that was different, but there is not one. It's just the same as the original problem. Number 5 is not very interesting, but you will come across problems like that. So let's go on to number 6. I need 2 numbers that multiply to 45. Quentin.
9 and 5.
9 and 5 will work. All right, then I have to go to each of these numbers and decide if it can break down. Can 9 break down? Yes, somebody new. Tell me what 9 breaks into. John. 3 times 3. Once you break a number down, you can kind of cross it off and ignore it. If you break a number down, you are no longer worried about that number. Can we break down 5 any further? No. So when we go to write our answer, we look for pairs. Do we have any pairs? What do we have a pair of? 3s. We have a pair of 3s, and then we have a 5 that's alone. If a number has a pair, those two numbers are going to become one. They're going to get stuck together, and it comes outside of the radical. So for this pair of the 3s, one of them comes outside the radical. They're like stuck together, they become 1, 3. What's left in the radical is anything that did not have a pair. So what's inside? The 5. And that is our answer. 3 radical 5 is how that would simplify. On number 12, I need two numbers that multiply to 12, Jordan. 4 and 3 will work. Can 4 break down further? Yes. What does 4 break into? 2 and 2. Does 3 break down further? No. Which numbers could I cross off right now that I don't care about? The 4 and the 12. Last year when I saw students doing these problems, I would still see students trying to use the 4 and the 12. Once you've broken it down, it's done. You don't use it anymore. What do I have a pair of? I have a pair of 2s, and which number is alone? The 3 is alone. So when I go to write my answer, what is outside the radical? 1, 2, what's inside? The 3. On these examples, these are different because we have a number out in front of the radical to begin with. That's fine. It's just going to hang out in front until the end, and then we will deal with it. So for now, leave that 5 that's out in front. Just let it hang out there. We're interested in the factors of 8. What two numbers would multiply to 8? 4 and 2. Which of those can get broken down further? What does it break into? Which numbers can I cross out right now? The 8 and the 4. We are not going to cross out this 5. We still need that to just hang out there. When we go to write our answer, the 5 stays out in front there. It's going to get multiplied to any other number we bring outside. What do I have a pair of? 2s, and what number is alone? The other 2. So it doesn't matter to me. If you want to circle those 2 as a pair and leave that one alone, it doesn't matter. You have a 2 that can come out front, and then you have a 2 that stays in the radical. For our final answer, we have to multiply the numbers that are out in front together. 5 times 2 is 10. If there were multiple numbers under your radical, you would multiply those back together also, but we don't have that on this problem. So our answer is 10 root 2. On number 9, once again, the number out in front is just going to hang out in front. It's not going anywhere for now. What we are interested in doing is breaking down the 125. So I need to know two numbers that multiply to give me 125. All right, so we know 125 can break into 5 times 25. Which of those two numbers can still break down? So 25 breaks into 5 and 5. Are we all okay with understanding why I stop? Like 5 can't break down any further, 2 couldn't break down any further. If your only option left is 1 times that number, you stop. You don't break it down any further. I have a pair of 5s, and I also have a lonely 5. Pair of 5s, lonely 5. Which numbers am I ignoring for the rest of this problem? The The 125 and the 25 are getting ignored. They got broken down, so we don't use them anymore. What number stays out in front from the beginning? 10. Times what number's joining it out front? What number is staying under the radical? 10 times 5 is 50. So our answer is 50 root 5. Questions on 9? All right, on number 10. Which number are we breaking down? The 48. What could 48 break into? Okay, we heard a couple options. We could use 4 and 12. We could use 2 and 24. We can use 6 and 8. 6 and 8 was the first one I heard, so that's the one I'm going to use. If you used a different factor pair, that's fine. Your answer in the end should come out the same. Can I break down 6? What does it break into? 3 and 2. 2 and 3, whichever way you want to write it. What about 8? 2 and 4. Which of these numbers can still get broken down? The 4 breaks into 2 and 2. Which numbers could I cross off right now? 4, 8, 6, and 48. Any number you break down, you are done with it. You do not have to go through and cross them off. If you already knew that and you understand that, that's fine. But if it helps you to ignore the numbers that you don't need, go ahead and cross them off. What do I have a pair of? How many pairs of 2 do I have? 2. I have a pair here, and even though this pair is split up, there's still a pair there. They don't have to be right next to each other to be considered a pair. So now I go to start writing my answer. What number is already out in front from the beginning of the problem? A 2. What else am I bringing out in front? Okay, I've got to bring a 2 from the pair at the bottom and another 2 from this other pair that was split up. What is alone under the radical? The 3. So out in front, I have to take 2 times 2 times 2, which gives me 8. 2 times 2 is 4, times 2 is 8. Radical 3. Again, if you end up with more than one thing that has to stay underneath your radical, those numbers get multiplied back together also. We just did not see that yet. You will see it on your worksheet.